Hi, I'm Lauren McCarthy and I'm going to be talking about my project, The Coalescence of Drying Droplets. So why should we study aerosol coalescence? Well, coalescence or collisions affect size distribution, and understanding the size distribution is fundamental to all areas of aerosol science. So if we go to look at the regime map here, the Weber number impact parameter regime map is a common way to represent collisional outcomes of two droplets. So the Weber number is a ratio of the fluid's inertial forces to its surface tension, and the impact parameter is a measure of how head-on the collision of the two droplets is. So figure 1 shows a typical regime map with the collisional outcomes labelled, as well as images depicting those outcomes. So how can collisional outcomes be observed? Well, figure 2 shows the initial setup. So voltage pulse is applied to the piezoelectric dispensers, which are aligned in order to collide the droplets. And the collisions are observed using stroboscopic imaging. This uses a white light LED, which is pulsed for roughly 500 nanoseconds at an evolving time delay from the voltage pulse. So once the collisional outcomes are observed, they can be plotted on the regime map. However, this setup is limited by the ability or inability of the dispensers to eject high viscosity droplets. So this is limited to about 20 millipascal seconds. So this experimental setup will not be suitable for investigating the viscosity dependence on the regime map in full. So instead, I'd like to design an instrument similar to the quadrupole setup in figure 3. So in this setup, two droplets of opposite charge are trapped in their own DC electrode, and once the droplets have dried, the upper electrode is switched off and the two droplets collide, and the resulting merged droplet is trapped in the lower electrode. So this allows more control over the initial and the merged droplets as they can be trapped. So what will my research strategy be? Well, in previous experiments have focused on the collision of larger droplets, greater than 100 microns. So my initial experiment will study two water droplets of roughly 40 microns in diameter, which is a novel size. I will then map the collisional outcomes on a regime map and compare this map to what has been previously mapped with larger droplets. And then following this, I'll use sucrose as a solute to increase the viscosity of the droplets. So once the dispensers are unable to eject the droplets in the sort of figure 2 setup, I will look at developing an instrument similar to figure 3 in order to control the drying time and therefore the viscosity prior to collision. There's also the option of adding Raman spectroscopy to either instrumentation to probe the morphology of the droplets.